0. Alright. This is a new vocabulary term we learned on Friday. If you weren't here, let's talk about it right now. Equivalent expressions. Equivalent expressions are always equal to each other. If the expressions have variables, they are equal whenever the same value is used for the variable in each expression. I'm going to talk about what that means. Okay? Remember, we were having this conversation about when is... Okay. Let's figure this out. Come on. When is... Remember we had to draw these diagrams? It was asking, when is x plus 3... When is x plus 3 equal to 3 plus x? When are these two things equal? Why?
Because
Who says always? Why?
they're the same thing, they just flip.
The order is flipped?
Yes.
The order is different? What if x was 1? What is 1 plus 3 then? 4. Is 1 plus 3 always going to be equal to 3 plus 1?
Yes.
What if x was 2? Is 2 plus 3 always going to equal 3 plus 2?
Yes.
What are these both equal?
5.
5. Thank you, Carl. Right, so always. What about when are x plus 2 and 3x equal? When were those two equal? When were your... Oh, Jordan, need your eyes up here. Gabby. Naomi. When were these two equal? Clarabelle? When x was 1. Only when x was 1. Why? 1 plus 2, is that equal to 3 times 1? What is 1 plus 2? Hayden and Eloise needs to stop. Is 3 always equal to 3?
Mm-hmm.
What if x was 2 here? Would these be equal? What's 2 plus 2?
4.
Is 4 equal to 3 times 2?
No.
No. Okay. So we're talking about equivalent expressions. These two expressions are equivalent when x is equal to what? 1. Okay? These two, let me say it again, are equivalent expressions when x is equal to what? 1. Are they always equivalent? No, only when what? These ones would be only when x is equal to 1. Okay? Then we were kind of getting into this controversy of why is 3x plus 4x equivalent to 5x plus 2x? Okay? Does anyone remember where we're going with this one? Why is 3x plus 4x equivalent to 5x plus 2x? I should see every single pair of eyes. This is so important. Why is 3x plus 4x equivalent to 5x plus 2x? Jordan.
Because 4 plus 3 equals 7 and 5 plus 2 equals 7.
Okay, I have 7 what though? 7 what?
7x.
I have 7 x's, right? How many x's do I have over here?
7x.
7x, right? We've talked about, like, if I draw a hanger diagram of these two things, here's my 3x, do a different color. There's my 4x. On this side, I'm going to have 2, 3. I have 5 x's, and how many more do I have? 2. How much do I have on each side of that hanger diagram, Porter?
What?
How much do I have on each side of that hanger diagram? Well, I have 4x, I have 3x right here, and then I have 4x right there, and then I have 5x here, and I have 2x here. On which side do I have 7?
Both.
I have both. Both sides I have the same amount of x's.
6 and 7.
Ooh, 6? Where do you see 6? Okay, so we don't want to confuse ourselves, right? This is saying when x is equal to 3, both sides will equal 21, right? If each of these boxes was 3, 3, 6, count for me, 9, 12,
18.
nope, 15,
Close.
18, 21. This side, 3. Come on, practice our 3. 6,
9,
12,
15,
18, 21. So if x was equal to 3, Each side would be equal to what? 21. We just counted that, okay? When are these two sides equal? Always, sometimes, or never?
Always.
Why always, Kaden?
Because they both equal 21 and that can never change.
What if x was 10 though? Would it change?
Yes.
Would they still always be equal?
Yes.
Count tens then. 10,
20,
30.
40, 50, 60, 70.
How much is this side worth?
70.
Okay, what if x was 10 over here? 10, 20.
30, 40, 50, 60, 70.
Are they equal?
Yes.
So if I put any number in there, will they always be equal? Why? Same number of what? Same number of x. 7 of everything. I like how you said that. Okay? How are we feeling about that? Matt, you look a little confused. Do you have a question? If you have a question, please ask me. I want to answer. How to, if x is 3.
Oh.
So each side has 7 groups of 3. Okay, so we're not goofing around. If you have a question, that's totally fine, but we're not messing around. Jordan?
Did you pick in the password?
I did. We're on the last day, too.
Yay.
So you guys know.
Yes.
Alright, how are we feeling? Equivalent expressions. We know an x is 10, all both sides are 70. Right? Okay. Let's move on. I wonder, Miss Jar, you said reciting right now? Please see that? Is that what she's done here?
Yeah, I think so.
Alright, we're going to identify equivalent expressions. This should be on page, I think we're going to stay in our groups this time because, oh actually, just kidding. Let's do whiteboard groups. Let's do whiteboard groups. Okay, are we ready? Alright, what I want you to do, what should you, 6th grade, tell me what you should do while I'm making the whiteboard groups. What's this new thing we've been doing? Jordan.
Not like complaining.
No, what's the new thing we've been doing while I get you into whiteboard groups? Winter. Reading the question to yourself quietly. Porter, Matt. You should be reading the question quietly, underlining or noting any information that you think is important to get into your quiz.
Oh, okay.
No, Matt, there are 270.
Okay, let's be paying attention. Pages on. Just Gage and Riley. Who sits there? Gage and Riley. Alright, are we ready? Did everyone read the question so you know what you're doing? So if I call in someone random, will they know what we're supposed to be doing? Okay, so take 10 seconds, read the question. What are you supposed to be doing? Oh. Okay, are we ready?
Yes.
Ready, go. 10, 9, 8, 7, 6, 5, 4, 3, 2,
You were just like,
1, 0. Alright, here's a list of expressions. Find any pairs that are equivalent. If you get stuck, draw tape diagrams or hanger diagrams. You have 3 minutes. Ready? 3 minutes.
Okay.
Not 5. You have 3. Okay, let's get started. Ooh, wait, we're saying 3 that are the same. If you have 3 groups of A, is that the same as having A and 3 more? No, that would be A. That would be A plus A.
How are you doing? Oh my god, I was
Just pick one and try to find a pair. If you're struggling, just pick one and try to find a pair. Got it. Okay, pick another one. Let's go. Pick another one and try to find a match. Ooh, are you saying A plus 3 equals 2? No. That's not how you write it. But also, if you're thinking 3A, you have 3 groups. Is that the same as having 1 group of A and 3 more? No. Okay. Keep going. Oh, Eloise, I want to see you writing the expressions down. Okay, so which one? You're saying A plus 3 over 2. 3 plus A was that one.
A divided by 1/3 equals Jordan, I've been telling you like 6 of them. There's a lot of A's. A times 3 equals 3A.
A divided by a third.
That makes you do A divided by 1/3 equals A over 3. And you also figure out the last two. What's A? What's A?
So this is saying A times a third. Is that
I can't.
A plus 3 is equal to. Okay. Where is next one? Okay, so you guys should be holding each
They said to write that down.
Okay.
That was my fault.
Oh, A. So you're saying A divided by 3 is the same as A plus A plus A? No, but multiplying by what is the same as dividing by 3? Okay, how are we doing? So this is saying 1/3 of some number A, and this one is saying A into 3 different groups. What are we thinking? Are those the only 2 I've left, right? And this one? So 2 of these have to match up. Should we So what if you what if you draw 2 diagrams? So you have A. How many pieces do you divide it into? Okay, this is saying 1/3 of A. So what if this whole thing is A? How many pieces are you dividing it into? 3. Or one of those, right? That's a third. Do they look the same? How are we feeling? They don't look the same?
Then you're okay, so
You say they don't look the same?
no, I didn't.
What is this? That's a third of A. What is this? That's a third of A. This is A cutting it into 3 pieces. This is A, one of the 3 pieces. Okay? So what about A divided by a third? What is that one? You would remember how do we do fractions? Can we do fractions of letters? We can't. A is just a number. How do you represent a number as a fraction? Like if it was 4. No.
Yeah.
Well, no. No, if A was 4, your fraction would be 4 over. No. What's a whole number as a fraction? What do you always put it over? 1, right? And if you're dividing by a third, you flip the second and you do it. So what is that saying? That's saying A times. where does that one match up to?
A.
Obviously,
All right, you have 30 seconds left. 30 seconds left.
One and then A.
What is that?
I'm a basketball.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right, I want you to pause. We're going to come back to these whiteboard groups, but for now I want you to go have a seat and get out your workbook. We're going to talk about it. 5, 4, you're ready and quiet in 3, 2, in 1, in 0. Show me with your body that you're ready. Show me. Do you guys see the board? If I stand here, I need you to see. Show me that you're ready. Okay, someone give me a pair that they thought of. I need every pair of eyes on me right now. I want your pencils down. I will give you time to write this down after we talk about it. But it's really hard to have a conversation and write at the same time. So what I want you to do is show me that you're listening. What is a pair? Naomi, what's a pair you found? 1A and A. 1A and A. Right? You have one group of A, which is just A. Nice. Ivy, what you got?
I did A plus 3 is equal to 3 plus A.
A plus 3 is equal to 3 plus A. Why do we know that? We've kind of already tested that one, right? Does the order matter when we add things? Does the order we add things matter? So is 2 plus 3 the same as 3 plus 2? Does it matter what order I put them in? No. These are always equal. Yes. Equivalent. Any others that we found? 1A is in fact equal to A. Clarabelle.
A
So-
times 3 is equal to A plus A.
Okay, wait, tell me that in one more second. I just want to cross out the ones we've done.
A
Okay, A,
times 3
A times 3.
is equal to A plus A plus A.
Why is that one equivalent?
And then, oh wait, there's one more.
Luke knows, but I want to give someone else another idea. Pencils down, pencils down. Eloise knows. I'm waiting. Christian knows. I want 2 more people.
Oh,
Do you know, Matt?
I know.
Okay, tell me.
Wait, is it, you know why they're the same? Or
Why?
No? Okay, so A times 3 is like A 3 times. And then the second one is A plus A plus A, which is A 3 times.
Okay. Does anyone else want to try to explain it a different way? Luke.
Multiplication is repeated addition.
Multiplication is repeated addition. We have talked about this. Is repeated addition. Challenge question. Exponents are repeated what?
Components.
Exponents are repeated what? Like if I have like this number. Exponents are repeated. We've learned about this. Multiplication. Exponents are repeated multiplication. Beautiful. So, 3 groups of A is the same as 1 group of A plus another group plus another group. If we were to draw this on a hanger diagram, they would look the same. You would have 3 A's on each side. Okay, someone give me, so we got, do we have another one we think is equal to that one? Is there another one that's equal to this one? Because we're missing one. Anila?
3A.
3A. There's an invisible, right? Our 3 is our what number? Our coefficient, and A is our variable. Our coefficient is the number being multiplied by our variable. There is an invisible multiplication sign in there. This is the same thing as this. Those two are the same. This one, the multiplication sign is just invisible. Okay, it's invisible math. You can tell your parents you learned about invisible math.
Whoa.
And that's a real thing.
no.
Okay. Someone give me another one they think is equal.
Sorry.
Jordan.